So thanks for the introductions, Serene. So I run the business and portfolio for data analytics for Dell EMC. A lot of you guys may be thinking, what does Dell EMC have to do with analytics? Well, Dell and EMC merged, as you guys know, last year. And we've essentially combined the two infrastructure portfolios of two companies. And we are building our solutions that are pre-integrated with a lot of the analytics stacks. Like Hadoop, SAS, Splunk, what have you, and we're offering them as solutions. So that's what we do at WMC. So I'm responsible for both the business side of the house as well as the portfolio side of the house for that. Prior to that, I used to run a product strategy for Pivotal, which is a Hadoop distribution. How many of you guys are technical? And how many of you guys are business side? All right, just give you that idea. So Pivotal is one of the Hadoop distributions. Hadoop is a big data technology. And prior to that, I ran services for analytics at Ericsson for 3 years, basically around telco analytics. And interestingly enough, I have a graduate school background in data science back in 1993. And we had my graduate coursework and all of that was paid by Mayo Clinic. And that was an NFS and the Mayo Clinic combined project around analysis of EEG signals from patients. So it was a healthcare analytics project. We were implementing what is called as nonlinear principal component analysis. So basically reducing the dimensionality of EEG data using nonlinear transformations. So that was back in 1993, right? And since then, I've kind of moved over to the business side. I've been on the business side for a long time. But the interesting fact is a lot of the algorithms and a lot of the mechanisms that we used back then are still very relevant today in data science, right? What's changed is the sophistication of the tools to run quickly, execute on projects, the availability of more data, and as a consequence of that, the general awareness in the industry around, hey, we got to do something about this because if we don't, the competition is going to do that and we'll be in a mess, right? So that really leads us to this topic around, how do you help business leaders understand how to successfully run, successfully implement and run advanced analytics projects, okay? So, to discuss that, we really need to understand what kind of, how do you come up with a taxonomy of how companies think about advanced analytics, right? And this is kind of my worldview of that at a 10,000-foot level, right? So we have companies whose sole sources of revenue is analytics based, right? And so those are, either the up-and-coming internet, data-driven companies like Uber, Amazon, Airbnb, Google, so forth, or they're companies that are doing primary research, right? Either life sciences research, genomics research, stock market analysis, environmental research, those kind of companies. But there are a lot of other companies in bread and butter companies, I would say, in different verticals, right? Healthcare vertical, telco, financial services, automotive, that are, their sole revenue source is not analytics, right? It's something else. So there's a gap in terms of senior management's commitment, right, within these two types of companies. Okay? So today we're going to focus on the companies on the left-hand side, right, and the bread and butter companies, and how do we get senior management to successfully, align with and fund and invest in advanced analytics projects. So if you go to the boardroom of a lot of these companies that are on the left-hand side of the previous chart, these are the kind of questions that get asked to the stakeholder that's actually running analytics practice, right? It could be a chief data officer, it could be a VP or director of data analytics. These are some of the questions that those guys get asked by the rest of the executive team, right? Okay, this is great technology. What is the return on investment? And when can I have it, right? How can I trust advanced analytics to make decisions on my behalf, right? Because I've been making decisions based on business intuition for decades, right? So now you're telling me a machine will tell me whether I'm right or whether I'm wrong. What are some of the hidden costs if you were to implement these kind of projects? And then what is the changes that we have to make in the organization to make this all happen? Okay. So these are the questions that Chief Data Officer or Data Analytics executive needs to be able to answer to the rest of the board. And that's a key thing, because you can talk about all these things until the cows come home, but until you have executive sponsorship in those companies that are kind of the bread and butter vertical companies, you're going to have a tough time actually getting funding and being successful in these engagements. So let's talk about all those things, right? Those 4 bullets. So let's start with return on investment for analytics. This is one of the toughest problems and the toughest questions that, frankly, none of the consulting companies, such as McKinsey or IBM or any of the large consulting companies, have a problem with a straightforward answer for this question, right? What is the return on investment for analytics? In my experience, it helps to look at it kind of like in the stock market, right? It's a trade-off between risk and reward, okay? So you have, let's say, stocks, and you have bond funds, right? You have stock funds and you have bond funds. So with stocks, you have a higher risk, but then you have higher potential for rate of return. In the bond funds, it's more predictable, right? In terms of risk and returns. So you can actually bifurcate analytics, advanced analytics use cases into 2 columns or 2 buckets. Cost and risk mitigation type use cases, right? You already have a cost of running your business or serving your customers or building products or operational costs. Or you already have risk in terms of either IT risk, financial risk, right? These are known entities that you're going through today. And so how do you contain those costs, right? So you come up with cost-saving use cases. Those are much more focused and narrow related to the column on the right-hand side, because you already know what those costs are that you're trying to save, right? And from the cost-saving use cases, then you say, okay, we want to build predictive models, right, that help us with those use cases. Where a lot of the companies kind of drop the ball is the arrow in dark blue, which is from the predictive models, you need to build out a cost savings model. That's what a lot of companies say, okay, we built a predictive model, let's go ahead and implement the project now, okay? But companies, as they mature in their thinking, would actually take that predictive model, build a cost model based on that predictive model, right, with probabilistic predictions. And then based on the cost model, they'll say, okay, this is the fixed cost of executing on this project, these are the life cycle costs, so this is my return on investment. Okay? And I've executed on several projects along these lines, cost and risk mitigation projects. Typically, I've seen anywhere between 50% to 300% return on investment. Okay, so you can say, okay, that's a very wide range, but it really depends on the type of use case you're talking about. Right? But it's still very quantifiable. Okay? In relation to the stuff on the right-hand side, which is revenue generation use cases. So oftentimes, these use cases are kind of like top-down use cases. Hey, we have this new market that we don't understand or we want to get into, right? We want to expand our addressable market space. So let's think of some use cases to do that. Let's build our predictive models. Let's build our revenue models. Those are more open-ended use cases. And that's why it's so hard to actually come up with meaningful revenue models that you can actually, commit to. Okay? So that's where a lot of companies look at ROI. There's a big question mark for a lot of companies, right? So for companies that are trying to mature on the left-hand side column, they're better off starting with the cost and risk mitigation type use cases. Okay? And the stuff that I've highlighted here are kind of the hidden costs, right? I know there's another talk on life cycle costs, right? Life cycle of data models. That's often overlooked, right? You have life cycle costs for solutions. You have life cycle costs for software products or hardware products. A lot of people don't really understand the life cycle costs of managing an analytical model. And that's because analytical models are built on assumptions that are driven by environmental factors. Environmental factors always change, right? So which means you have to constantly look at the model and update it. So those costs are real costs that are oftentimes underestimated in projects. Okay, so here's the other part of it, right? How do you get executive management to start trusting advanced analytics, right? The technology behind it, okay? And IBM had proposed this kind of a maturity model, right, for advanced analytics. They start off with descriptive, predictive, and prescriptive model. And it was really, very thoughtful, right, to have this kind of a model. And almost like 10, 15 years ago, I think they came up with this model. But since then, there's been a lot of confusion and debate about what's predictive and what's prescriptive, right? And at the end of the day, you have to ask yourself, does it really matter if you're doing a predictive analytics project or if you're doing a prescriptive analytics project? The reason it matters, in my view, is because you can actually think of the trust that management places in analytics projects based on these terms, right? In my view, if predictive model is where management is willing to launch advanced analytics projects, but doesn't necessarily trust everything about that project, right? So they want, it's kind of like a newborn baby, right? You don't trust it. Whereas in a prescriptive model, you have developed trust, right? Your child is 20 years old, he's starting to, stand on his own feet, right? So that's a level of, it's a level of trust that business places into the analytics projects that in a way defines whether the model is prescriptive or predictive. So let's talk about those two models, or evolution between those two models, right? So we start off with the predictive model. So in the predictive model, obviously there's a model and what the model provides, and then there's the business intuition, right? Should we expand the business in this area, or how do we mitigate churn for our customers, or how do we change our product portfolio, those kind of things. So the predictive model, so the atom going from the predictive model to the business intuition is kind of narrow or thin, because the business guys don't really trust that model yet. I mean, they're getting data from it, but they have their own notion of what is right and wrong. And on the other side, the atom going in the opposite direction is thick or broad, because the business manager has to do a lot of babysitting of the model, right? They need to explain to the model, make sure the assumptions are right, make sure the model is doing the right thing. And as a result, the predictive model is often applied to a small segment of what we call the target business entities, okay? Target business entities is nothing but customers, or products, or your services or operations. So if you have, let's say you're Verizon, you have 100 million customers, right? And you want to build a predictive model for containing churn. Well, you're not going to apply that model to 100 million customers, right? You're going to take a small subset of that, see how it works. If you're a Starbucks and you want to launch oatmeal, you're not going to launch it nationwide, right? You're going to take a small sample of stores, launch it, see how it works. So those are the attributes of the predictive model. The other aspect of the predictive model is how it interprets data from the environment, right? So at that level, you're not quite sure how to actually make meaningful use of environmental data. So that's why that arrow from the environment is kind of thin, right? Now, switching to the prescriptive model, here's where the model has grown up. So the model is able to provide really strong prescriptive, right, decisions towards the business folks, right? And the business folks don't have to babysit the model as much because the model in a way is self-learning, right? It's taking environmental parameters and it's actually learning how the environment is changing. So you're not needing to babysit the model because it's actually using the environmental variables much more effectively. And it's also targeting a larger segment of your target business entities. So you're applying that model to 80% of your customers or 80% of your products. Right? So that's the way to think of it. So when senior management says, how can I trust the technology? Then you say, okay, let's start with a predictive model, right? Start small and then iterate. Okay. So the last part, business and organizational structures. So this is a really tricky part, right? Because the senior management is looking at it and saying, okay, how are these new analytics projects going to impact how we do business, right? And what the organizational structure means, right? Here also it behooves companies to take a kind of a gradual maturity approach, right? So we start off with, you have IT, you have different lines of business, maybe different business units, and then you have corporate, right? So oftentimes what companies do is they say, okay, let's try to get a couple of use cases addressed around the cost mitigation space, right? And oftentimes companies find out that their data is spread across multiple data stores, enterprise data warehouses, what have you. So they have to do some sort of a federation of data, right? And that's always not easy, both from a procedural point of view as well as from a technology point of view. Because a lot of these data sources are from different vendors. Right? One's from Oracle, one's from IBM, the other one's from Teradata. How do you federate data across the board? Okay? So that's one of the common challenges that companies face when they're trying to do this kind of analytics. And the other aspect of this is when you start sharing data across these different equivalent data sources, you get into issue of data integrity, data lineage, data ownership, data management, data security, right? Those are all issues that you need to grapple with. Okay. So the higher level of maturity there is really having a analytics initiative or initiatives driven from the management side, where you have a stakeholder in the company, such as a chief data officer or a VP or director of analytics, and you have different business units and different entities within the organization, and you have kind of a more of a hierarchical structure. Right? So there are some advantages to this. As you all know, in data science, the more sources of information you have, the higher the probability the predictions are going to be more meaningful. So by being able to correlate data across multiple sources in one place, you're able to do better, more effective analytics. Economies of scale, right? You need to hire one pool of data scientists and one pool of analytics BI folks, right? And then be able to essentially offer the service across the board in the company. The data ownership boundaries are not as significant or severe as in the previous model, right? Because you say, okay, you own your data, but I'm going to get a copy, read-only copy of it, and you have a clear sense of boundaries of ownership in that case. One of the biggest costs here in doing this is data migration projects, right? And this is, again, a lot of companies underestimate the amount of data migration projects that they have to accomplish. So for example, Citibank is doing a consolidated data lake project, and the data migration aspect of it is it's going to cost them $2 billion, right, globally. Huge project, right? So those costs are often underestimated. And then obviously organizational changes, right? When you have organizational changes, you have kind of collateral changes that you have to take care of as well. So that's kind of the maturity model from an organizational point of view. So, all right. So that's really all I have. Is at the end of the day, baby steps, right? Walk before run is what it means, and it's important to set the right expectations to executive management. There are too many analytics projects, too many Hadoop projects that I've seen that companies embark on because it's going to look great on their resumes, but they kind of stall because they're not being able to tie it back to business outcomes. That's all I had.
Now open to questions.
And by the way, I'm an immigrant too, but I don't have that cool T-shirt, so. Yeah.
Hey, I have a question about the maturity model that you just showed.
Yeah.
So the proposal of your evolution is to centralize. One challenge that may happen when you centralize is that the data scientists become an ivory tower full of data scientists and far away from the business. And I think part of the value of the data scientist is understanding how the business works well. How do you address that type of problem in an organization? And is this problem much bigger if the organization is large?
Yeah, that's a great question, right? So whenever you centralize a function, you always get into the siloed effect, right? The centralized organization becomes an ivory tower. They're a different organization. So there are a couple of ways to do it, right? So I've seen in organizations where you have representatives from each of those business units, also part of that team. They may not be an expert data scientist, but they attend those meetings and then they give constant feedback and provide the checks and balances. I've also seen where the data science guy is expected to essentially do like a sabbatical, right? Maybe some part of the folks there actually go work with some of these organizations, understand what the business issues are at a one-on-one level as opposed to sitting on an ivory tower and kind of driving it that way. So I've seen it both ways, but again, it takes an organizational will and planning to be able to do that. But yeah, absolutely. The larger the team, the more issues you're going to have of having that ivory tower effect.
So what you just said, your presentation resonates very well with me, so thank you very much for that. One of the things you said right at the very end was you've seen a lot of the big projects, a lot of these big data projects, not being able to be tied to business value. In my experience, because of the nature of the big data projects, because they're overarching, they have so many different business cases that they can fulfill. It's a little hard sometimes to target in on the business side. Can you speak a little bit in your experience about how you've been successful with that?
Absolutely, absolutely. So it very much has to do with this actually. So and oftentimes, the companies they want to build a data lake and then start looking at use cases to go fetch, right? So typically it's been kind of an IT-led engagement. What we've done from us, when I was running services and even with Dell EMC, when we offer these solutions, we often approach the lines of business and try to nail down some use cases for them. At least 2 use cases, not 1, but 2 use cases. Okay? If it's one use case, you don't need a platform. You need a vertically integrated solution, and off you go, off you run. There's nothing wrong with that, right? Analytics has existed a long time before Hadoop or any of these technologies came along. So you need at least 2 use cases. And they have to have sponsorship from the line of business. So you go talk to the line of business, get sponsorship for 2 use cases, and then you implement only the scope of those 2 use cases on your Hadoop data lake. And then you expand from that. So the syndrome where you have a data lake and you're fishing out for use cases is kind of the tail wagging the dog, if you will. And it really speaks to the fact that you're lacking the discipline of taking that first step, right, on the left-hand side there.
This one is like, if someone wants to switch their career into data science,
Right.
how they get started? Because
Yeah.
if you don't have work is experience, you don't get experience, you don't get job.
Right. Great question. Great question. Chicken and egg problem, right? So the first thing you do is to get exposed to other data scientists, right? So if you have a team, so typically if you look at any kind of services engagement for advanced analytics projects, you have 1 or 2 data scientists, right? You don't have a lot of them, right? 1 or 2 guys. And then you have a bunch of BI folks who are really good at slicing and dicing data, writing OLAP queries and stuff like that. You have a few architects who put together the stack for you and who integrate with other IT systems, right? And then you have the infrastructure guys who do the hardware, rack and stack configuration, those kind of things. So it depends on where you are, right? You could be any one of those other guys that wants to do data science, right? Or you could be, for example, you have a computer science degree. Well, you could be a big data architect, right? Who understands how to configure these Hadoop stacks or SAS or Splunk or whatever analytics stacks you have. So you could start off there. And then you have to essentially, it's kind of like an osmosis thing, right? You start working more and more with the data science guys, understand, what their ways of working are, what the best practices are from them. On the alternative, in parallel, what you'll have to do is to actually get the core capabilities, right? You have to, so statistics, right? Analytical models. You need to have an understanding of that. If you look at the evolution of software, right? I was a computer science graduate from way back when. I wrote assembly code. I wrote low-level code, and then I kind of switched over to the business side just when people started only using Java, right? So I never actually learned to program in Java. So, so a similar type of evolution is happening in the data science industry, right? So I talked about how back in '93 we were doing nonlinear PCA algorithms. Well, we were actually hard-coding our algorithms on connection machines, okay? And today, there are a ton of startup companies and even mature companies that are basically data science for dummies type tools, right? Those tools are great because you don't need to understand how the algorithms work in a very detailed way to be able to implement some of these projects. On the flip side, you may run into issues that you will not be able to get out of, right? It's like, it's like the initial days of Java, right? Where people didn't really understand garbage collection. And they're like, why is my program sucking, right? And I'm doing everything right. Well, there are things that are happening under the covers that you're not aware of. So the industry is kind of in that phase of evolution right now where you still need to understand the concepts of statistics, for probabilistic models and stuff like that, even if you use those tools. Okay? And the vendors of the tools will tell you that they can get anybody on the street and just give them the tool and they'll be a data scientist. That's not really the case.
Sai, one question.
Yeah.
I authored 2 books on IoT.
Okay.
And my experience from semiconductor business before I transitioned here showed me that one of the principal reasons ROIs are low in the industry is because of poor or diminishing consumer purchasing power of people. So industry also has to take, because this is the consideration that for the IoT to become a revolution, supply and demand both have to grow. So unless that aspect of economics is addressed, I don't know how we'll have an ROIs when we just can just manufacture as much as we can, but we're not finding sufficient consumption.
Right. So the ROI model that I talked about was more of a typical IT, BI, analytics practice in any run-of-the-mill company, right? When you're talking about IoT devices and IoT type use cases, the ROI equation kind of changes, right? Because then you're absolutely right. It's a question of how do you balance supply and demand. I think, in a way, that question is can also be asked as what are the compelling IoT use cases where the returns are meaningful to warrant the investment, right? So that supply and demand question, I think, matching that up is similar to the ROI question in terms of, I would probably categorize that as kind of more the revenue column, right? Even though you're talking about, so actually that's a great point. I mean, you could actually use the same taxonomy for IoT devices too, right? And IoT use cases, you can say, okay, what are the IoT use cases, say in manufacturing or heavy machinery, automotive, that represent cost savings for me? How much is the cost savings for doing proactive maintenance on heavy machinery, for instance, or any of these things, or fraud detection, right? And you could have revenue type use cases. So I think that particular model you can actually apply to IoT use cases, not just for enterprise IT use cases.
Yes, sir. Coming to the return of investment again, if you go back to the slide, the most important thing, which is again, I mean, as you told, is the life cycle costs which are playing in anywhere in the project. So many of the customers whom we speak just ask, okay, will I get some ROI this year?
Right.
If I implement 2017, at the end of 2017, will I see? And we all know that implementing big data projects or something takes time.
Right.
And then we say, oh, the answer is anywhere not closer to that, because it takes X number of hours or time to build even that use case to get into reality and predictive model. It's all the learning curve there.
Right.
So is there a kind of a benchmark, we say, typically a 24 months life cycle which will help you to get ROI closer to what we have seen there? Or should I say that, okay, it's like again the old way of doing BI, where you have bottom up and top down approach, both were playing. Somebody was saying you want to ROI, got to the bottom up approach. Somebody was saying you want an enterprise warehouse, build a top down approach.
Right. So from a time frame perspective, I mean, obviously a lot depends on use cases, but typical expectation is don't pick use cases where you cannot justify an ROI within 6 months. If you're thinking of use cases where you say, okay, I'm going to have great ROI in 18 months, chunk that up, right? Split it up. Because that's the tolerance level for a lot of the management teams, these 6 months.
From a business leader perspective and also a tech type guy, would you try to maximize more revenue generation or cost and risk mitigation?
Cost.
In what case, where do you see in the future? Because from a business leader perspective, you want to generate probably more revenue, but as a, let's say as a software engineer, you want to try and do more cost saving.
Right.
So where would you say, what do you want to maximize more of?
Right. So that's a great question. So from a business leader point of view, they're looking at risk, right? Risk mitigation overall for the business, okay? While they're investing. Oftentimes, business leaders want to get returns on one engagement and then use that returns to then funnel growth. That's how most business leaders think, right? So a lot of business leaders are looking at this and saying, okay, let me fund the cost and risk mitigation projects. Let's get the ROI in place, and from that ROI, I'm going to go ahead and fund revenue generation projects. Kind of a bootstrap, right? Instead of putting in money from outside the pond, you're actually generating revenues, and then you're repurposing those, or cost savings, and repurposing those cost savings to then build more advanced technologies. One more question, maybe? All right. One more question.
In your experience, I'm a consultant, and so I'd like from your experience, some of the things, what are some of the language you use maybe to persuade the board into some of these technologies that is not overbearing, that is not like going to drown them, and stuff that they don't know and they're confused about, and immediately that triggers the fear, that triggers that I don't want to go there. In your experience, what are some of the things that, or some of the resources we can look into so we can share that with them?
Okay. So, unfortunately, I mean, there are a few books and resources that have started to surface. I've been to a lot of the Hadoop conferences over the last 6-7 years, and the first few years I thought it was a joke, because it's like there's no talk or discussion about any of the business or use cases. It was all about technology and Flume and Spark and these kind of things. So I think that is maturing. You're starting to see more and more material come up on these kind of the business discussions. I would put all your business discussions I would articulate them in terms of these kind of things, right? ROI, NPV, net present value of whatever project you're going to engage on, right? A time frame for returns, like the 6-month time frame is really a good psychological barrier for a lot of management folks. So I mean, I don't think there's any kind of secret sauce to any of this, right? It's like any other new engagement where you have to explain it in terms that they understand, and just business terms in general. And the key thing to emphasize is you need to be able to take the predictive models and then build it out into cost savings models, right? And oftentimes you can actually go in there and you can say, okay, I predict the return on investment to be between this and this, right? Which oftentimes the business leaders are like, okay, you've done your homework. Think of confidence intervals, for those of you guys who've done statistics, right? You have the 5% confidence interval, right? Same thing here. Okay.
Okay, great.
Thank you.